We're going to begin talking about Laplace transforms. Here's the definition. We'll come back to that in a minute. Here's an example to perhaps motivate the idea of the Laplace transform. We have the familiar, what should be the familiar equation for an oscillatory system with a drag force. And we set the equation for the net force on the system equal to some driving force, F of t, with initial conditions, y of 0 equals y naught, y prime of 0 equals v naught, and this could be a t0 instead of just 0. Now let's suppose that we do have some sort of an oscillatory system, a spring mass dash top, let's see if I can say that right, a spring mass dash pot system. Try saying that a few times fast. It's surprisingly difficult. With mass m, drag coefficient gamma, and restoring force k. But we don't know what these three parameters are. We haven't measured them. We want to measure them by applying some force function and looking at what comes out of the system, looking at the output of the system. That is, drive it with some force function and measure or somehow observe the resulting motion function, y of t, the position function that describes the motion. Having done so, can we recover the values of m, gamma, and k, which again, we assume for some reason we don't know? Well, we can take this equation and we could solve it using variation of parameters. Without going through all the details or writing out the form of the solution, you know that we're going to end up integrating f multiplied by some combination of y1 and y2, where y1 and y2 is a fundamental set for the homogeneous equation. And it even goes further than that. We're going to do that integral. We're going to multiply the result of that integral by some combination of y1 and y2. Didn't say that quite right, but you know the process. The point is that m, gamma, and k are going to get so tied up inside of sine and cosine and exponential functions and so forth that it's going to be very difficult, if not impossible, to solve our resulting solution for those three parameters. Now, as an alternative, there's a way, and we're going to see that rather soon. There is a way to transform this equation into an algebraic equation. Okay, this is a differential equation. You've got to use calculus to solve it. We can translate this into an equation depending on the function f of t, as long as f of t, if f of t is a sine or a cosine function, or even some kind of a square wave function where we push, pull with constant force, changing instantly from one constant to another, anything of that nature, we can transform this equation into an algebraic equation. We can solve the equation and in the process solve for m, gamma, and k, and recover that information. And that can be very useful in engineering applications. We observe the function that we use to force a system, and the system might be complicated. We might not have any way to isolate measurements of mass, drag force, and restoring force, but by applying some sort of a force function, we can recover the values of m, gamma, and k by simply observing the function y that results from our force function with the given initial conditions. Usually the initial conditions are going to be everything at rest, so y naught and v naught would both be 0. Okay, to do that, we have this thing called the Laplace transform. And the Laplace transform applied to a function f of t, it is just an integral. We integrate from 0 to infinity, and the integral is the integral of f of s e to the negative st I wrote that down wrong, realized it as I read it. F of t, e to the negative st, with respect to t. Now we'll see how this integral works out. We'll do this integral for some common functions, exponential functions, f of t, sine and cosine functions, powers of t, and then we'll work out a couple other properties of this transform, and those properties will allow us to to transform an equation like this into an algebraic equation. We just do algebra, add and subtract the same quantity from both sides, no calculus, simple, not always simple, but basic algebra, something you would have learned to do if you did a good job in Algebra 2.